Hi everyone, my name is Feng and I recently received my PhD in mathematics. Today, I would like to tell you about some of the spaces that I studied in my PhD research and how such spaces can help computer systems like Google Translate or automated phone systems deal better with human language. Here by space, I mean any set of points where we have a way of measuring distances and sometimes also angles between those points. And we will see concrete examples of these very shortly. Spaces I want to tell you about today are negatively curved. What on earth does that mean? Let's start with something more familiar. The space we're used to living in and moving through is flat. It has zero curvature, or at least locally it does. The surface of the Earth as a whole is actually approximately a sphere. And we need to take this into account when sailing or flying across oceans, for example. The surface of a sphere is positively curved. One thing this means, something which is characteristic of positive curvature, is that if two people were to set off in different directions from the same spot on Earth, and they kept going straight along the surface of the Earth, which means they end up going along great circles like the equator or the longitudes, those two people would eventually meet again on the other side of the Earth from where they started. Compare this to what happens in a flat space. If two ants were to set off in different directions from the same spot on a flat piece of paper, and they kept going in straight lines, those ants would never meet again. For this illustration, you should imagine that it's an endless and bounded piece of paper. Or if you don't like infinite paper, that the ants fall off the paper when they reach the edge. If those critters were to do the same thing in a negatively curved space, start at the same spot and head off straight in different directions, not only would they never meet again, they would spread apart really, really quickly. If you were traveling in a negatively curved space, you had better be sure that you are going in exactly the direction you wanted to be. Suppose you and your friend were to start at the same spot somewhere on Earth, say in a giant meadow, so you didn't have to worry about bumping into buildings or stuff. And suppose you headed off in just slightly different directions and kept going straight at about the same speed. Suppose after a while you decide you want to join your friend where they are. That seems like a fun place to be. You would have to walk a little bit to get to where your friend is, but that distance would be quite a bit less than how far you had already walked. If you were in the same situation in a negatively curved space, the distance you would have to walk to get to your friend would be much larger. You might be wondering, what does a negatively curved space even look like? Imagine a crinkly kale leaf. The surface of that leaf is negatively curved in the ways described above. Related to this, a patch on the kale leaf has much more area than we might expect, given its radius. And this is why you can't lay the leaf flat down on the tabletop or cutting board. We can use this last idea to knit our own negatively curved spaces by adding stitches as we crochet, although I have to confess I don't actually know how to knit myself, so let me not talk more about this bit. Do negatively curved spaces actually exist in our world outside of salads and knitting projects? Einstein's theory of general relativity tells us that yes, parts of our universe are modeled by negatively curved spacetimes. Closer to Earth, though not exactly more visible, are the negatively curved spaces that certain computer applications use in some of their computations. For instance, imagine you had a computer program that wanted to do something with a human language sentence. As part of this, it is often useful to have a measure of how similar words are to one another. One way of obtaining such a measure of similarity is to start with a space, say the flat two-dimensional space of a piece of paper, or of your computer screen, where we have a way of measuring distances between points, and assign to each word a point in that space. We might try to do this in a way that puts words that should be more similar closer together. For example, cat and dog might be placed relatively close together, while kitten and hammer might be placed further apart. In practice, this often works out better if we do it in a negatively curved space. And this seems to be related to some sort of hierarchical structure between words. Dog and cat and kitten might be placed together with some other words under mammal, which might be grouped together with yet more words under animal, and so on and so forth. At each level of this hierarchy, there's a great deal of branching out, and it is easier to accommodate this amount of branching out in the negatively curved space. How do we work with or study negatively curved spaces? Do we spend a whole bunch of time staring really closely at kale leaves and making minute measurements on them? Well, sometimes it does feel like that when we want really precise distances and angles and have to work very hard and do a bunch of tedious computations. But sometimes we can be lazy and skip most of the computations and get by taking advantage of some key aspects, such as how area piles up much faster or how straight lines spread apart much more quickly. Another characteristic feature of negative curvature related to the earlier two is that triangles in negatively curved spaces are thin, like tripods or trees, not actual trees, but things that could be stick figure representations of trees in winter. Thin triangles are not always enough, but surprisingly often enough to give us the distance estimates we need in applications. To sum up, kale leaves are examples of negatively curved spaces that we can hold in our hands. Spaces like these can help Google Translate perform better. And in working with these spaces, it is often helpful to zoom out and focus on their large-scale qualitative features. Thank you for listening.